Hi folks, Mr. Teslonian back here again. We're doing some unique science experiments with our Wimshurst electrostatic generator. And what you see right here is I've got a large spark gap set up with the top of a little Tesla coil sitting between those spark gaps, allowing that spark to hit one side and then back out the other. I have the top here connected to our large secondary coil, which in this case is actually our primary coil, going all the way down to the bottom of our secondary coil, which in a standard Tesla coil would be your primary. I've got my positive for the meter, as you can see right here. I've got it wedged in there on our secondary coil, making an electrical connection. I've got the negative from our primary coil running down here with the negative from my meter, both plugged into the ground lead of an extension cord off of my main house ground. So I've grounded both of those leads, making sure that they're grounded out. The negative here runs over to my meter. The positive here goes over to the meter. What I'm going to do now is go ahead and fire this thing up and show you how we're using this to create DC and AC voltage. It's more of a pure AC than it is a DC voltage. So let me go ahead and set the camera up here for you. Got tools everywhere because of working on this. I'm going to go ahead and just do this all right here live for you. Zoom in on the meter. Alright, so you should be able to see that, I hope. Let me zoom in a little bit more for you. Alright, so there you go. That should give you a reading right there off of the meter. I'm going to go over here. I'm going to turn the meter first to DC voltage. Let me turn that screen around so I can see. Alright, so it is showing there. What is that? It's going down now. It's losing its charge. It's the original fire-up charge on the meter. Alright, so we're watching the DC voltage go all the way down and kind of settle out there. I'm going to start turning the crank. You notice immediately a DC voltage present, and every time you hear the spark in the background, the DC voltage shorts out and goes away. So there's a direct conversion from our Wimshurst electrostatic generator wirelessly through the air to the top of our Tesla coil, converting that to a usable DC current. Now let me go ahead and rotate that over to an AC current. Now watch this. You notice already we're at 1 volt. 1.6, 1.8, 1.9 per second. And it doesn't seem to get better when I go faster. There's like this perfect medium point in there. So there you go. That's actually creating 1.5 to 2 volts worth of AC current, through the air wirelessly from our high voltage static generator to our Tesla coil and into our meter, turning this static electric discharge into usable voltage. I mean, that 1.2 volts right there, converted over with a converter, would convert to charge a 1.2 volt battery. Let me get that going again, see if we can't jump the 2. There we go, I saw the 2 for a second. It's overloading it because some of it is different currents. So there you go. When you slow it down, it'll stay more constant. So there you go. There's a 1.8, 1.9 per minute. If I go too fast, I'll get a short out. Alright, so there's AC voltage from our Wimshurst electrostatic generator. Let me go ahead and walk you back around. Kind of show you once again what we've got going on here. Alright, so I show you here from the meter all the way over to there. We've got it hooked to our secondary coil there on the Tesla coil, as you can see, and we've got it hooked to our ground over here on our extension cord, and that's exactly what's creating the current here. We're allowing our coil to be grounded, and you've got to do that with both the meter and the ground from the coil. The main primary coil here, and all we're allowing it to do is discharge between the tops of those balls onto the top of our Tesla coil, and that's actually converting static electric discharge into a usable AC voltage that we can now convert into something that we could even charge a 1.2 volt battery. This can be done from long distance with a much bigger machine, using this to transmit wireless electricity to your home from your generator. Immediately on the voltage on that meter. And you should be able to see the sparks actually traveling from the spark gap balls to the top of the Tesla coil. And as you see that, you should actually be able to watch the spikes on that meter. Alright, I thought I'd throw this into the middle of the video here. I wanted you to both see the meter reading and watch the sparks hitting the top of that Tesla coil at the same time. You should be able to actually see on the meter. If I go too fast, it'll start to overload exactly in the same time as the sparks. And if I slow it back down, you should see the voltage basically crest off to the 1 point something volts there, upwards of 1.8, 1.9 volts, and it becomes much more steady of a current. If I go too fast, you watch it start overloading, and that may just be due to the size of our Tesla coil can't actually handle the size of a surge going into it. So there you go, there's a neat demonstration of wirelessly converting static electricity through a Tesla coil into usable AC current. I hope you enjoyed. Until next time, this is Mr. Teslonian and the Teslonian Man Show. Alright folks, I want to take you through briefly what you were just witness to, why it works, and the original design of what the Tesla coil was designed to do. Tesla never designed this thing to just be some fancy device in a science class broadcasting electrical sparks all over in the air. This is a reception antenna. There's a little bit of design difference between the actual direct reception antenna and the Tesla coil. Not a lot, but the basic principles still work with the standard Tesla coil. As you were just witness to in that last film, you actually noticed that the voltage on the meter was the same as when the actual arc was directly in contact, leaving from one point to the other across the top of the Tesla coil. In the last film, there was no direct arc, maybe just a couple. What we were doing is charging the atmosphere between the 2 points, basically focusing a highly charged particle beam, in a lot of respects a plasma beam, across from this point to this point, and it's broadcasting into the air around that. And this Tesla coil is grabbing that highly charged ionic discharge from these 2 points and converting that high frequency ionic discharge into a usable current that we can use at home for other things. This design now can also be used to broadcast from one point to another with reception in towers between these 2 points. Let's say we had massive capacitor towers hooked to a massive, in this case, a Wimshurst electrostatic generator. Anywhere, let's say they were 100 yards apart. Between these 2 points, you could put up a Tesla coil anywhere between those, as long as the voltage in the capacitors, the charge between them was high enough to charge the atmosphere between the 2 points to create the plasma discharge. So what I'm going to do now is extend this range. I'm going to build a bunch more capacitors so we can increase the actual charge that'll be emanated between these 2 points. And I'll show you how to use a capacitor as a battery bank, basically, and we can deplete that capacitor slower over time by slowly depleting the ionic charge without direct contact from a Tesla coil, making a capacitor more like a battery. Typically, capacitors dump their charge immediately, and they don't like holding onto it and releasing it at any kind of a slow rate. But with this design, I can actually charge these capacitors with the right distance set up. I can actually pull that current off at a much slower rate, basically turning them into a dry battery, something that would be really beneficial today in science and green technology and other forms that we really need a chemical-free dry battery system. And capacitors have been there since the ancient days of Egypt and beyond as laden. Alright folks, what you see there on the meter as voltage is actually leftover residual current still bleeding out of my capacitors at a slow rate into the meter. It'll take a while for that to actually deplete the entire battery, basically. These are dry batteries, and I found a way to basically slowly discharge capacitors and create something that we can now convert into an AC current. You should be watching that slowly fade down. Alright, so as I start to turn the Wimshurst generator here, you should start seeing a difference immediately on the voltage on that meter. And you should be able to see the sparks actually traveling from the spark gap balls to the top of the Tesla coil. And as you see that, you should actually be able to watch the spikes on that meter.